From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez.
Crossing from one industry to the other. What really helped me was because I was crossing from biomedical, which at that time had the most reach and most use for additive manufacturing. So when we're thinking about the pioneers or the starters of additive manufacturing, we think about aerospace and biomedical. So I started from where 3D printing started, really. And being able to be in the position where you guys are really one of the first to start using the technology, as I move from that to automotive, as you know, biomedical is very stringent and there are so many rules, so many regulations that guides how we operate. So coming from an industry where quality has to be top notch because human lives were involved, I learned a lot about quality control, being able to follow the rules to make sure that you can take this technology to the next level, maybe from your bench test to in vivo experiments to human trials, right? So learning that stringent, everything must be done right. Now it's moving to aerospace where, yes, they also have their procedures. Everything has to be done right, but they don't need Health Canada and FDA, right? It's a different sort of rules, but the rules are sort of similar.
That was Addy Olubamiji. Addy is an advanced manufacturing technical advisor at Cummins. She joins the podcast to discuss her career in 3D printing, having been involved in the medical, aerospace, and automotive sectors. Addy also talks about her inspirational work with the STEMHub Foundation, which is an organization she founded to help underrepresented youth pursue opportunities in STEM. Well, thank you, Addy, for joining us for the conversation today. Just getting started, kind of looking at your background as a bit of an introduction. You started kind of your life out of PhD as a biomedical engineer. How did you end up doing additive manufacturing lately now with Cummins?
Thank you, Mike, for having me on the show. I'm very excited to actually be talking to someone that's part of the COVID situation that we're in. So I got to hear about 3D printing actually in my master's degree in Finland. So I did my master's degree at Tampere University of Technology, and it was focused also on biomedical engineering, but I took a minor in material research. So during this time, I got a little introduction into what 3D printing is like and what the future would be in terms of medical equipment and things related to that. Then when I moved into my PhD, I decided to focus a whole lot on material research, material science, biomaterials, and really how to understand different materials that are used for biomedical products. So this is how I found out about biomedical engineering. And for my PhD, I focused on fabrication of 3D printed cartilage. And pretty much 3D printing was half of my PhD thesis. So that's how I got into 3D printing, but for biomedical applications. Over time, I got to realize that 3D printing is like a one-stop shop. Everyone can participate, whatever, regardless of what areas you're working on, whether you are in biomedical or aerospace or automotive or even consumable manufacturing. So I kind of, during my master's degree, not only limit myself to just the polymeric 3D printing approach for biomedical applications, to broaden my view and understand some basic principles necessary for me to be able to transition from plastic to metal 3D printing for not only material that are associated with biomedical applications. So that's how I started. Originally, my bachelor's was in physics. So my interest in imaging and using imaging techniques to visualize materials was how I fell in love with materials. So wanting to understand, if I choose this imaging approach, can it work when I have multi-materials? What are the things in materials that I need to understand to make sure the X-rays can penetrate effectively? That's how my love for materials came to life. So wanting to combine material knowledge with medical imaging knowledge, but eventually ending up on the materials side, more on the 3D printing side. But that's how I started, and have been able to transition pretty much from medical applications. Then I moved on to 3D printing for aerospace applications. And now using 3D printing in the automotive world, it's been fulfilling and exciting at the same time.
Awesome. And what are some of the common threads between the different industries? Do you think of it as um, different spaces, or is it kind of one space in terms of 3D printing and materials, just kind of some different applications? How do you think about kind of the overlaps and differences between the sectors that you've worked in?
So I think there are few differences, but there is one thing that unites us all. We're all dealing with materials, whether it is metal, plastic, or ceramic, or even sand. Knowing, having that basic of how materials work, what is the process associated with processing materials, understanding how to characterize materials, was what really helped make my transition easy. In terms of how they differ. They differ greatly. As you know, 3D printing have multiple branches, right? From binder jetting to powder bed fusion, to lamination, sheet lamination. You know, it's a variety of possibility. That's why I call it a one-stop shop. So I believe that when you have that basic knowledge of 3D printing, transitioning from one technology to another may not be that challenging. I think if you have really settled with one of those technology, understand the nuances and how it operates, when you're faced with another technology, you will take your lessons learned from your first technology and be able to transition with ease. Not really with ease, but you would be able to at least not fall. You may stumble slightly during your learning processes when you're crossing to another technology. Now, crossing from one industry to the other. What really helped me was because I was crossing from biomedical, which at that time had the most reach and most use for additive manufacturing. So when we're thinking about the pioneers or the starters of additive manufacturing, we think about aerospace and biomedical. So I started from where 3D printing started, really. And being able to be in the position where you guys are really one of the first to start using the technology, as I move from that to automotive, as you know, biomedical is very stringent, and there are so many rules, so many regulations that guides how we operate. So coming from an industry where quality has to be top notch because human lives were involved, I learned a lot about quality control, being able to follow the rules to make sure that you can take this technology to the next level, maybe from your bench test to in vivo experiments to human trials, right? So learning that stringent, everything must be done right. Now it's moving to aerospace where, yes, they also have their procedures. Everything has to be done right, but they don't need Health Canada and FDA, right? It's a different sort of rules, but the rules are sort of similar. So I'm very thankful that I started from one of the areas where quality control was the best, like it was rigorous. Moving to another areas where there is still a very high level of rigorousness required, and now transitioning to automotive where, yeah, the laws are a little more flexible. So coming from very hard, rigorous process to a little more flexibility helped me understand the full picture of what is required to be able to not only just do additive manufacturing, but to commercialize, to regularize, to standardize, right? I don't know if that answers your question.
Yeah.
Transitioning has been exciting for me because I know so much that has to be done. To, all right, they don't need all of it. Do you need 60% of it? You're still good to go, right?
Right. And I'm sure along the way, it's not like this road was kind of fully paved, right? Like even within aerospace and biomedical, there's still things everyone's learning every day about these different technologies, the way materials interact with the 3D printing process as a whole. So I'm guessing
Absolutely.
there's things you learn and that you're kind of building upon, regardless of how strict the industry is.
Yes, I would say one of the reasons why I'm in this industry is the fact that I get bored easily. I need something that is evolving, challenging. a job that challenges me every day, technology that makes me know you have to keep learning. You can't just say, I know it all. And additive manufacturing offers that because it's very new. One of the streamlines of Industry 4.0. It's new, is still evolving. There is a lot of opportunities in terms of what is needed for us to standardize the technology. So I'm really thankful for that, for the opportunity to keep learning as the technology evolve, that we also evolve with it. Are we there yet? Are we at that point where we feel like, yes, it's good. It's now really good. We are not. So
Then we'll just get rid of all the materials engineers and our job will be done.
yes.
So the other thing I really like about your background is you've had experience in a lot of different geographies of in Canada and the US, and you just mentioned Finland. How has that shaped some of your approaches to the technology? Do you see any patterns emerging from different places that you've been and that you've worked from a geography perspective?
Yes, I do see a little bit of difference. So for the Europe landscape, the Europe landscape is very entrepreneurial focused. So coming out, you can do a university project and you can take that and transform that into a company or a product or write a patent, and then you can just industrialize that or commercialize that. For the Canadian side, we were not focused on, we want to continue to research because we felt like it's still evolving. It's still evolving. Let's do a little more research. Let's do a little more research. It's not that stable too much. So I saw that difference as soon as I moved to Finland and to Canada for my PhD. That on the Europe side, we weren't really excited about publishing papers. We just wanted to commercialize. But in Canada, the focus was on, oh, let's still write a couple of more research papers and and get everything to a point where we have more confidence in the technology. But I would, and this is why we can see that from the Europe perspective, there's so many companies being created on a daily basis, focusing on not just even additive manufacturing, focusing on manufacturing and engineering needs, different equipments being commercialized because of how their system works by growing engineers into innovators and entrepreneurs and product owners. So I really enjoyed working and going to school in Europe because of that mentality. Now bringing that to Canada, I also love the fact that in Canada, I can focus on in-depth research, really wanting to know this to the last point, to that perfect point. I also appreciate that because I wanted to actually be a master of something. I want to know something and know that I know a lot about this and not just make it a product straight, right? So I also appreciate that in-depth learning that Canada provided when I was doing my PhD there. Now on the US side, I think there's a combination of both. Here in the US. You can, there is the entrepreneurial plus the deep learning merging together to give you products. And if somebody wants to become a professor, you can go that way and still own products. So I really do appreciate the perspective that the US brings into making engineers into product owners, but still letting them be in-depth learners, subject matter experts. So that's how I see the three different countries that I've lived in. And this has really shaped who I am as a person. So when I look at how I approach problems, I want to solve it in depth, but I'm also every day thinking about, all right, how can we make money out of all the science experiments that we're doing?
Did you
Because
have
of
Did you ever have an inclination to stay in academia, or were you always pushed more towards the commercial, entrepreneurial kind of company space?
I like I said, the whole experience shaped my person. Every day when I go to work, I remember that I'm a researcher, even if I'm doing it to make money. On thinking about academia, in fact, I have been thinking about academia recently a whole lot because when I was in Canada working, I acted as a principal liaison officer within the between the company that I work for and University of Waterloo. So I had an office there. I had students that I co-supervised. I love that. I enjoyed that because of the flexibility of being able to work and also being able to still mentor, coach, and supervise students. So I'm currently considering maybe an adjunct professor opportunity because I do not see myself as someone who can really go into academia full time. But I think I can still make a lot of impact in the area of research. So I'm considering taking up a position as an adjunct professor.
One of the things that I've observed in the industry is this kind of growing collaboration between the academic space and commercial space, and kind of the commercial space and companies giving targets for universities to direct some of their research. And how have you found kind of that interaction between companies and universities grow over the time that you've been in the space, kind of coming from both starting the academic side, but then kind of now in the last few years on commercial and aerospace and automotive?
I think that relationship, that three-way relationship, is a necessity for our industry. And the reason for that is because additive manufacturing is still growing, and there's a lot of research that we need to consider to do for us to be able to move specifically for different technologies and different needs. Most companies cannot afford to hire a whole lot of people to do this research. It's too expensive. We can't afford to have people just focusing on research without having to bring in money. So we can utilize the partnerships with university to drive those research that we are interested in for our products without having to be the owners of those research. So I believe for any company who is well vested and thinking about sophisticated additive manufacturing, that it is very important to have university to partner with them and take some research from off their hands, go get them done, but you still get to contribute while they're doing that research. You still get to give them feedback, participate as a co-supervisor of those projects. I think it's a necessity for a field that is evolving the way our industry is evolving.
Sure. And for the last several years, you've been the Advanced Manufacturing Technical Advisor at Cummins. So I'm always curious about how people move to different roles and find different positions. What was what's the story there?
Um, so when I got hired to work at Cummins, my job is get get to teach people about this technology, get to talk about it, get to share about this technology. Over the years, in the last 2 years, we've had a lot of migration where after engineers get to understand the technology, they now had a part of additive into their work. It could be 25% of their work plan, 50% of their work plan, focusing on additive, and then they've grown into the knowledge of the technology. We've not had to hire people solely who are just focusing on additive. We've had to work on teaching and really utilizing the workforce that we have by teaching them what they need to know about additive and utilizing their knowledge of our company and the different business units that we have. So we don't have to train new people about this 100-year-old company and spend too many years training them. So that's how we've done it. We are spreading the knowledge within the company, raising additive champions, and these champions are now not only just understanding the technology, they are becoming experts in different areas from design to materials to process. That's how we have approached it internally at Cummins. When Cummins hired me as their first additive manufacturing engineer, I was thinking maybe, oh, by now we will have 5 new hires. But what I found out is we didn't need 5 new hires. We need to populate this technology for it to be accepted by the company. And that's the approach Cummins has used. And I think it's great.
And do you think, kind of going forward, that the trend more is to retrain or augment mechanical engineers, materials engineers with the background of additive manufacturing, or do you see a growing need for some of the academic kind of programs that are popping up around the country and around the world that are specifically focused on 3D printing? Is there a way, like if I'm a mechanical engineer or materials engineer, how do you recommend people kind of getting into the industry, and what background would you be looking for folks?
So I think a combination of both will work, right? Cummins took a step of faith, hiring me, and now I train people to learn about the technology, or they work with me to kind of get their knowledge bank full. I think that's a good thing. You hire a few experts and you retrain the workforce that you have. The reason for that is because the Industry 4.0 era that we have just entered is going to be here for 40 to 50 years. If we are not retraining our workforce, they're going to be obsolete because technologies are advancing, right? So we will need to retrain our workforce on the new technologies, on new areas that they have to kind of learn to remain competitive. But we also need new programs that will now teach this so that we can have experts who can come in and help us retrain the workforce. So, and those experts also will learn from our workforce. Like when I joined Cummins and up till now, I'm still learning about the automotive industry because I came from aerospace and biomedical. So there is a lot of cross learning going on. So I'm learning about the automotive industry. I'm learning about how Cummins do manufacturing, and then I'm teaching about how additive manufacturing works and how they need to unlearn for you to be able to succeed in this industry. You need to unlearn some principles, or you have to put them in the back and not kind of try to say why is additive doing that. We haven't done that for 100 years that way. This is the additive way. So I think a combination of both. It is very important for university to put that as part of their curriculums, additive related skills, additive related curriculums, because when we want to hire new people, we are specifically not only looking for people that we will train, we're looking for people who will come and hit the ground running. So we need them to come with some level of expertise. We need, because we are just, especially for a lot of companies that are just getting into technology, they don't know what they don't know. So you can't give us a half-baked student who you just taught 3 courses on additive. They need to come with in-depth knowledge of the technology so they can help us train our workforce while they also learn. That's how I think we can work together and not say university don't need to train people on additive. Yes, they need to, but we also need to not leave behind the engineers who are already working, who had no knowledge of additive.
What's the biggest, I guess, knowledge gap from, as you've had experience training the experienced engineers? Is there something that stands out in terms of the technology that makes it conceptually different or conceptually challenging for people to understand?
Um, or an area where we just kind of struggle.
Yeah.
I think an area where, based on the different places I've worked or my experience reading different articles, where people have continued to struggle is really, I'll call it the manufacturing execution system, the MES system, the data management portion of additive. As you know, this machine is producing data from its various systems and subsystems every time when it prints. So being able to capture those data and make real-time interpretation of those data so you can understand how your machine is behaving and why over time. What is its degradation rate? What's happening? That is an area that a lot of companies have not really grasped how they're going to work with the data that we're generating. And it's tons of data. And how do I make those real-time decisions based on this data that I'm getting? That's one area. The other area is linking up the whole ecosystem of additive, where from the beginning of the process, which is your design, to the end of your process, linking up those could be a little challenging from company to company based on the size of additive that you're dealing with. So if you're dealing with one machine, it may not be as challenging, but if you're thinking of we want to industrialize, that traceability is an area that could be challenging. The third area, under design. So design engineers are known and saying, I'm going to do my design. I'm going to have a drawing. I'm going to send that drawing, and they're going to machine my part. They're doing machining to that. in additive, you may have four different designs. You may have the final design, the compensated design with no support, the one with support, the build, the slice file. That's too many designs. How do we manage all these different designs such that people are able to control those information and have traceability? Is also another area that is driving a lot of discussion, especially when you're dealing with legacy engineers. You have to really explain to them and drive this home and to be able to keep traceability.
For sure. And I think for a company like Cummins and many others, even aerospace, automotive, it's not just how does the part and the machine perform today and what does the materials look like, but thinking parts are in the field for 3, 4, 5, 10, 20 years. And how do we start to learn what those best practices are to make sure that something is going to last? And even more so, how do we make sure that if we have a part that breaks down, can we build it again in the same way and get the same properties out with the same or different machines? So I agree with you completely that that's an ongoing challenge, but I think an exciting one because there's just so many fields that come into it. There's materials, there's data analysis, there's mechanical testing, and it all comes together.
Yep. And the one that I didn't mention that I want to mention quickly is controls and robotics. Oh God, when it comes to controls, I think it's just a beast because the equipment itself is acting as a robot, and that piece, because I'm a physicist, so it loses me every time.
Fantastic. And kind of switching gears a little bit, I've kind of followed your LinkedIn. I think we, just for everyone, a little bit of a history. So I think we met maybe 2 years ago at AMUG,
Yeah.
and have just been keeping in touch throughout the industry and run into each other at different conferences. Kind of in addition to the additive work that you're doing on a daily basis, you've started another organization called the STEMHub Foundation. Can you talk a little bit more about that?
Yeah, I can do that. And thank you for asking me about STEMHub. I started STEMHub about 3 years ago. It's a Canadian non-for-profit that focuses on offering hands-on STEM outreach programs in Ontario to minority communities. We also provide free mentorship programs to entry-level or mid-level professionals who are looking to understand what they need to do to be able to be successful in their careers. So those are our two major focuses. I think so far it's been a journey. So in 2017, when I finished my PhD officially in graduate convocation and convocated, there were a lot of people who reached out to me talking about biomedical engineering is very new. And for people in the Black community, it's non-existent. So when I graduated as the first Black person to receive a PhD in biomedical engineering from University of Saskatchewan, and that program was already 30 years old at at that time.
That's
So
amazing.
people were asking, why did it take 30 years for us to have one Black person think this was a good idea? And I told them, well, it was because people from our community just kind of stay into doing traditional engineering, which is safer. And so there were discussions in the community about, what is the future of engineering? How can we get young people into this future fields? And I thought maybe it was a good idea to come together with some of my friends and create STEMHub and use this platform as an opportunity to educate young people about the future of engineering and also help them get into STEM by people cannot people cannot be what they cannot see. So we thought if they see more of us and hear about the work we do and have access to us to mentor, to coach, to support them, maybe it will also encourage more minority youths, more young women to want to go into STEM. it's been 3 years old, and it's been 3 years, and it's 3 years old, and I'm very proud of the work that we've done. So our reach went from just focusing on Canada, and people from my original home, which is Nigeria, started asking, "How do you want to support us?" So we expanded to Nigeria and to other countries within Africa. So we're very proud of how we have not only expanded but also grew our social media reach. On Instagram, we have about 25,000 followers, and they're mostly young people and their parents, just following what is it that we are doing, for them to know how to kind of navigate. So that's what STEMHub does, and I believe that all of us can play a part apart from just doing our engineering jobs and just having a good time there. We can play a role in our communities to raise the future leaders.
That's awesome. And I love the way you phrase it. You can't be what you can't see. And just manufacturing in general has a very stereotypical perception of who works in manufacturing, right? I mean, at least certainly in the US. And to show people that there are cool jobs there and that the path isn't impossible to go down one that you've gone down and be successful and gain traction and become a leader in the industry. I think that's really fantastic. It's something that I think is very commendable.
Thank you. I I find it as something I need to say every time. I love manufacturing. I think it's it's funny because it's people don't expect you to like it, but I do love it. I leave my job. I'm happy with the work we're doing, especially with the opportunities that Additive Manufacturing offers. And it's still within manufacturing. It's unbelievable that this field is as exciting as it is, but it is one of the best decisions that I've made with my life so far.
Yeah. And have you faced challenges kind of being kind of a minority in manufacturing? Has that ever kind of come up in any conversations or perceptions along your career path? I know for me, there's been kind of certainly challenges along the way that have different conversations that have come up with that are somewhat unexpected, but I think everyone's path is slightly different. But have you faced any of those challenges?
I think I have good and bad news on the challenges side.
Yeah.
I think just being a visible minority in manufacturing, and it's sometimes in the beginning of my manufacturing journey, I was a little scared, ask a couple of questions of myself whether I'm worthy to be the one doing this job. But yes, there will always be people who don't believe in you or who just want you to prove yourself that you're worthy of that position. And I love a good challenge. I love it when I see someone doubting me by the first question they ask you is, "What school did you go?" But I have also I've taken it upon myself that sometimes people need to be convinced that I know what I'm doing. So I think I have trained myself to not see those as a negativity, but an opportunity to educate somebody as to what I can do, as to what people who look like me can do. I also want to recognize that throughout my little journey that is still proceeding, I have enjoyed allyship. I have had allies, mentors, mentors who have appointed themselves and are just interested in how is Addy going to prove everybody wrong in a good way. And they have continued to mentor, coach, train, support me as I grow. And I just want to mention two names. I hope I could send them this podcast. Currently have three mentors. One of them, Lisa Farrell. She's a director at Cummins. This woman goes above and beyond to make sure that I'm confident, that I'm thoughtful, that I'm still applying critical thinking, that I'm still doing research while making money for the company. She supports me. And when I want to describe my journey, I feel like she's a pathfinder because, like I mentioned, you cannot be what you cannot see. She also have a PhD. So when I look at, she has a PhD, she's been able to go this far at Cummins, and these are all the achievements that she had. And she's not only just a role model, she's standing beside me every day and saying, Hadi, this is how you're gonna go. So I've enjoyed a lot of allyship from that, from a lot of people who have helped me through some of my challenges. On the male side, I have Kelly Schmidt, one of our executive directors, who constantly just not only support me but nominate me for the best things ever, like awards, all the good things happening. It supports my work. So I want to say this to any minority person who can be listening to this. You need your allies as your sponsors, as your mentors. You cannot do this alone. Challenges are normal. Yes, they go in. They can be small for some people. They can be more for you, but you can turn that around and use it in your favor. You can also turn that around and use that as an opportunity to teach someone. And I have learned to do both of those over this course of my little career that is just evolving. Um, I wouldn't be able to point specifically to one greater challenge or the greatest challenge. I just want to point to the fact that all of those challenges had led me to maybe my next promotion, maybe my next publication, maybe meeting somebody else who is today helping me. I have used them as a stepping stone to get something out of whatever I was going through. Life itself is hard, Mike.
Yes. Going back to the mentorship, how do you, for someone in the engineering field or even any field in general, like how do you find mentors? What's that first conversation like with them, or like how do you kind of build that relationship with someone that's going to be meaningful and kind of fruitful for both parties?
So I think, how did I found Lisa? My last role within Cummins before I got promoted, my boss, my manager then, we talked, and I told him I really do need a mentor. I'm new to the US. I'm new to this role. I'm new to everything. Yes, I come with all this knowledge, but I need a mentor to be able to put the pieces together and learn how to lead by influence. So he went ahead and found Lisa for me as a mentor. On my second mentor, how I found him. So my second mentor, he leads New Recon Parts Additive Manufacturing Development, and I was supporting uh, that area um, during my last role. So because I was supporting that area, he regularly just talked to me about how things are going, if or when I need to support them, just reach out and say we need your help and all that. And I realized that this guy has a whole lot of achievements. So I felt like I needed to kind of, build a relationship with him. So we started by talking a lot about additive manufacturing, about what I bring to the table, because every mentor also wants to know what is it that he can learn from you, right? And we talk a lot about additive manufacturing, and he is also very interested in STEM education for the community. He's a community builder. So we talked a lot about, now that I live here, what organization should I join to be able to contribute to growing STEM education and outreach in Indiana? So this was how we connected. And freely, he was giving me good advices. So I realized, I need to just make this formal. So I asked him to be my mentor. This could be very daunting for young people who are wondering, who can I pick as a mentor? I think before you make such pick, you need to think about, what is your big picture? What is your 5-year goal? Where do you want to be in 5 years? And when you look at that big picture, then you can find someone who is living in that big picture. and build a relationship with them. First, by trying to do for them instead of them doing for you. Look for what is it that you can do for that mentor. How can you contribute to their work? And when you start to do for them, they get familiar with you. They naturally will give back to you. So as they start to give back to you, then you can make it official. I think this has really helped me found my second and third mentor by giving to them first, and over time requesting that they formally start to give back to me. And I literally know that they are where I want to be 5 years from now.
So I think we'll end it there. And as we do end, can you give the people listening some more information on if they want to check out more about Cummins or your STEMHub Foundation? Any links or places we can send them to? We'll add those to the end of the podcast as well. But if there's anything specific that you want to point people towards, please let them know.
Yeah, if you're interested in learning a bit about my work, I did a TEDx talk on my PhD thesis where I used 3D printing for manufacturing articular cartilage scaffolds. You can check that TEDx talk out. You can also check out some of the news on Cummins' website talking about how we are investing in 3D printing, the different areas that we're focusing our investments. And lastly, please check out STEMHub Foundation. And we are looking for more mentors, and you don't have to be Black. We're looking for more mentors. We're looking for people who can help us to continue to show young people how cool STEM education is. So please check us out if you are interested in mentoring or contributing through facilitating sessions for us. We are taking remote facilitators. Currently, we're all our programs are virtual. So you don't have to travel to Canada to be able to do a design workshop for our youth. So please reach out to me on LinkedIn at Addy Olubamiji, or reach out to us at STEMHub if you're interested in helping us facilitate any tech sessions virtually. Mike, thank you very much for the opportunity to share on this program today. I really do appreciate it.
Thank you so much.